Welcome to Computer Graphics and Visualization subject, that is Module 1. In that module we are discussing overview of computer graphics. Today we will discuss line drawing algorithms which we will use normally in drawing lines in computer graphics subject, that is line drawing algorithms. Before going to line drawing algorithms, some useful definitions we will discuss. What do we mean by rasterization? Process of determining which pixel provide the best approximation to a desired line on the screen. Means the rasterization is a process when you are drawing with respect to line. If I describe this definition with respect to line, this is the definition. Otherwise, rasterization normally is converting your geometric input to digital output is called rasterization. But with respect to line, if I define this one, it is a process of approximating the values between line starting point and end point. Nothing but when you are drawing a line in computer graphics, normally you will give input starting point and end point. Only we are providing starting and end point of that line. Other intermediate points has to be automatically calculated. Then who is going to calculate it automatically? Definitely there are algorithms, right? Then what is the rule? What is the role of the algorithms? They have to calculate what is the next pixel, because I have given only in this input and this input, means starting point and end point I have given. But when it is drawing this line, definitely on monitor it might have covered n number of intermediate pixels. N number of intermediate pixels, nothing but input you have given. Starting and end point is nothing but what? Starting pixel you have given, starting pixel value you have given, end pixel value you have given. Then what about these pixels? Who has given these pixels? Then how this line will come to know that I have to switch on this pixel, because there may be n number of pixels. Right? How my line will come to know that I have to switch on this pixel, I have to switch on this pixel. That will be decided by line drawing algorithm. Means which next pixel I have to switch on, so that that line goes straight, looks like a straight line, and this line has to end here only, and that line has to end here only, because they have given end point. Programmer has given the end point of that line. That line should not end somewhere here, because whatever end point you have given, it has to go there and it has to end there. Right? That's why first starting point he has given, it has to switch on that pixel, because he has given the starting point. Then next point, when it is going next point, then it has to decide which next point is, that has to be calculated. Those will be done by line drawing algorithms. Means it has to, every time it has to calculate next pixel. During this process, again there is a one problem. If you take this as an example, it has assumed that it has switched on this, right? Or assume that it has switched on this. Then after that it has to calculate next pixel. Which next pixel I have to switch on, it has to calculate. In this case, what is the problem with this line? This line has intersected some part in this pixel, then remaining part is this pixel. Among these two pixels, which pixel then it has to switch on? Right? Again same problem here also. Here this line again it has intersected, means it has crossed two pixels here. Then which pixel? Right? That decision has to be made by these line drawing algorithms. Right? Then next is the scan conversion, combination of rasterization and generating the picture in a scan line order. These are the frequently we use these words, rasterization and scan conversion. These are meaning of rasterization and scan conversion. Then first we will discuss the algorithm, that is algorithm which is available in computer graphics. That is very simple algorithm. This is a DDA algorithm, that is digital differential analyzer. DDA means digital differential analyzer, right? Then if you take this as an example, means I would like to draw one line, that is A and B. Means only I will give input A, input B. What is A? A is nothing but I will give x1 y1 values, I will give x2 y2 value. Means only I am providing starting point of my line, that is x1 y1, then the end point of my line, that is x2 y2. Then whatever intermediate pixels it has calculated, who has calculated, definitely algorithms will calculate those. Right? During this calculation, definitely these problems they will face. That they have to approximate. This is the meaning of that has to be approximated here. Algorithms has to approximate either whether I have to select this pixel or this pixel. That is left to the algorithm. It only picks only one pixel, then switches on that pixel. Right? This will be done. That is what means only first time I have given input x1 y1. Then after that next pixel. Then after that next pixel. Then after that next pixel, like this up to x2 y2. This is the end. Up to x2 y2, it has to calculate all intermediate pixels, then proper pixels it has to switch on, so that my line at the end, my line has to look like a straight line. has to look like a straight line, right? That decision has to be made by these algorithms, right? That is how to do this one. Then how this algorithm works, DDA algorithm works. DDA algorithm takes straight line equation, that is straight line equation is y equal to mx plus b. If line has two endpoints, that is a and b, x1 y1 and b is x2 y2. Then here all of you know how to calculate slope of a line. Slope of a line is m equal to y2 minus y1 by x2 minus x1, right? Y2 minus y1 is nothing but delta y, x2 minus x1 is nothing but delta x, that is m equal to delta y and delta x. Same equation we have simplified, that is y2 minus y1 we will call it as a delta y, that is difference between y2 minus y1, then difference between x2 minus x1, that is delta x, right? Basically this algorithm is based on the calculation of values delta x and delta y. This algorithm is based on the calculation of delta x and delta y. Therefore delta y equal to m into delta x, means if you calculate delta y, then delta y, this delta x goes this side, that is delta y equal to m into delta x, this. Then if you take out delta x, then delta x will come this side, m will come this side, that is delta x equal to delta y by m. That is equation number 1 and 2. Means basically this works on delta x and delta y, right? Given line has a slope positive or negative. Given line may have slope positive or negative depending on how you are giving input, right? If you are giving input from left to right, then you will get a positive slope. If you are given input from right to left, then you will get a slope, negative slope, right? If slope is positive, then delta x and delta y values are increased. If slope is positive, then you are incrementing delta x and delta y. If slope is negative, you are decrementing delta x and delta y, right? Then if the positive slope, if the positive value of a slope, that is m is less than or equal to 1, slope is positive but value of slope is less than or equal to 1, then we set a delta x equal to 1. We set delta x equal to 1, and the next y point value you have to calculate. If this slope of line is like this, means less than or equal to 1, I know what is delta x. Delta x is always 1. Delta x is always 1. Only we will get a problem in y, whether which y I have to select. Which y I have to select? Nothing but delta x is 1 is nothing but what? You know what is the next x. When you are drawing that line, you know what is the next x. If previous x is 0, then in next x is 1. Then what is the next x? Next x is 2. Then next x is 3. Next x is 4, 5, 6 like this. Means I know x increment, but I will face a problem in y, because in y whether I have to pick yk or yk plus 1. Whether means yk is nothing but whether I have to pick the what pixel I have drawn. If for example if you have drawn 0, 0, 0 pixel previously, if you have switched on 0, 0 pixel previously, then in x direction definitely you have to switch on 1th pixel in x direction, because in previous pixel is in x direction 0, y direction 0. Previous pixel number is in x direction 0, y direction 0. In this case, you know what is next x. What is next x? To previous x you have to add 1. To previous x you have to add n. Previously x was 0. If you add 1, then you will get 1. Means next x you know, but which y? Whether you have to take same y, whatever y you have selected for previous pixel, or you have to take new y, right? That means whether you have to take 0th y, means are you drawing same line y, or you are taking moving above 1 pixel. That we have to decide here. When slope is this, if slope is this, then we will get a problem in y. We will not get a problem in x, because always x will increment 1, but we will face a problem in y, right? If I take this example here, means assume I will take this. For example, if you have switched on this pixel, assume that you have switched on this pixel, that is 0, 0. Then in that case, you know what is the next x. Means you have to come right to this. Means x you are incrementing some in this. X is 1. X is 1. Means x is 1 anywhere here. X is 1 here. But I have to calculate y, because if that line goes like this, in this case, how it has gone, if that line goes like this, means it has started here, it is coming like this, it is coming like this, means some part of that line is here, then some part is here. Then x I know, x is 1, here also x is 1, here also x is 1, but which y? Then I have to select this y or this y, because this y is different, this y is different. This y is 0, this y is 1. This y is 1, this y is 0. Since my line has intersected both the pixels, that's why I will get a confusion here, whether this y I have to pick or this y. there is no problem with x, because x in this line is x is remains same. If you pick this y, or if you pick this y, or if you pick this y or this y, x remains same. That's why I know in x, but I will get a confusion in y if that line intersects both the pixel. If that line intersects exactly like this, then I will not get any problem, but most of the time that line may go like this. That is what the meaning of this line. That is what meaning of this line here, right? Y point you have to calculate. Then how to calculate y point means, when you have drawn current y, then you are confusion about which y, next y, that is yk plus 1. When you are at current yk, when you are here, when you are current yk, then you have problem with yk plus 1. Which yk plus 1, whether I have to go to next y or I have to remain in previous y only. That is yk plus 1 equal to yk plus m. Yk plus 1 equal to yk plus m. Then how we got, again you substitute here. That is what yk. This is yk plus 1 minus yk. If I elaborate this one, this is yk plus 1 minus yk, right? Then I want yk plus 1. That's why yk plus 1 I will keep this side. Then minus yk I will move right side. Yk I will move right side. This is a minus yk. This time it will come plus yk. That is plus yk plus yk plus m into delta x. Yk, that is yk plus m into delta x. That again I have simplified. That is yk plus 1 yk plus m, right? Then that simplification, that is what equation number 3. Then where k equal to 1 and increased by 1, in k always you increment by 1, because till if you reach end point, that is x2, till x2 you have to always point which new y. Once you reach end point of x, then you stop this one. Then so value of y is also converted into integer. Here what is happening, here yk is integer, yk plus 1 is integer, but what about m? Always you will get a floating point, because m is delta y by delta x. Always you are getting a floating point. Once you get a floating point, if you add with the integer, you will get result floating point. That's why y also converted, means y we have to convert into integer. Means here floating point result. Why you have to convert into integer? Because since floating point operations take more time. Floating point operations will take more time compared to integer operations, right? If you are drawing complex object by using this algorithm, then there may be many such equations may come. If all equations you are using floating point operation, then definitely your execution of your program will become very slow. Right? That is what, if you take this m floating point, then definitely we will get program execution slow. But we have to convert that one integer. Then how that will be converted, we will see. Right? But ultimately you will get floating point result here, because m, if you are taking a m is delta y by delta x. Definitely that is a floating point operation. Floating point operations will take more time, right? Then we have to convert y into integer. To convert y into integer, definitely we have to do some operations, right? If the positive value of slope m is greater than 1, then delta y, at that time you are drawing line like this, always you are incrementing in y, but you will get a confusion in x. That is what delta y, then x you have to calculate. That is xk equal to xk plus 1 by m. Here xk equal to xk plus 1 by m. That is what xk plus 1 minus xk. If you take xk plus 1, then if it xk plus xk comes this side, then xk plus delta y by m, that is xk plus here xk plus 1 by m. Because you know what is delta x, delta y, here delta y, if you substitute, then this will become 1 by m, all those, then this equation becomes 4. Then here you have to calculate x when your slope is greater than 1. If your slope is less than 1, you have to calculate y. Means you will get confusion in y when slope is less than 1. When slope is greater than 1, you will get confusion in x. You know why. Y is always incremented by 1, right? So above two equations are used, those lines whose endpoints left to right. Means we are assuming that positive increment in delta x and delta y. Positively we are incrementing in delta x, and means we have given starting point this here, end point this side, means left to right. We are moving from left to right. If you are coming from right to left, then here you have to decrement. Right? Here, if the line from right to left, then x and y values are decreased. x and y values are decreased. So equations are yk plus 1 equal to yk minus m. If this is the case, then xk plus 1 equal to xk minus 1 by m. If this is positive slope, then plus you will get. If it is a negative slope, then you will get minus here, right? Then algorithm, how this algorithm works, then input two line endpoints, a, that is x1 y1, and b x2 y2, and start with the left endpoint, that is you start here. You start from here, declare delta x, delta y, steps k, x increment, y increment, x and y. All whatever constants you require, all the constants you declare here. Then start calculating. Calculate delta x, delta y. That is x2 minus x1, y2 minus y1. Then step 3. If ABS of delta x, absolute value of delta x is greater than absolute value of delta y, steps equal to delta x. Absolute value of delta x means how many steps you have to repeat this algorithm. How many steps you have to repeat that algorithm, that you have to calculate. If delta x is greater than delta y, if delta x is greater than delta y, steps equal to delta y means nothing but you are moving in x direction. You are moving in x direction. Else steps equal to delta y means you are moving in y direction always. You are moving in y direction, right? Then step number 4, we have x increment equal to, you have to calculate x increment equal to delta x by number of steps, x increment equal to delta x by number of steps, y increment to delta y by number of steps, right? X increment equal to delta x by steps, y increment equal to delta y by steps. Then step 5, set pixel round x1, round y1. Then this is color. This is the color, means here as I told, you will get floating point x, floating point y, because in both the equation you have m. Both the equation you have m. Here also you have m. Here also you have. Definitely the result, new x and y, whatever new x and y you are getting, those will get a floating point. Once you get a floating point, they will why you are rounding here, why you are rounding. Before going to that floating point problem, why you are rounding? Because on monitor pixel numbers are integers. There is no floating point pixels. You cannot number floating point pixels on monitor. Whatever pixel we are representing on monitor, everything is an integer. Means monitor is an integer representation. But if you get 2.5, assume that you got one x value 2.5, then there is no pixel number 2.5 on monitor. 2 or 3, 1, 2, 3 like this. Pixel numbers are numbered in integers. 1, 2, 3, 4, 5. But if you get pixel value 2.3 or something, then how will you represent that value? That's why you have to round up. You have to round up means you have to take integer. You have to convert whatever floating point you got, that you have to take integer part. Right here also, because y also you may get like that, because in both, as I told, in both the equation you have m. M is nothing but delta y by delta x. Definitely both may result floating point result, but there are no floating point pixels on monitor. Always pixels are numbered in integer. That's why you have to round, right? But when you are doing rounding operation, nothing but you are converting from floating point to integer. These functions will take more time. These functions will take more. This is disadvantage of this algorithm. Basically, this is a disadvantage of this algorithm. Means floating point conversion requires more time, right? That is what the disadvantage. We will discuss disadvantage at the end of this explanation, means slide. Now x equal to x plus, then next draw that one, then calculate next value. That is x. New x is x plus x increment, y equal to y plus y increment. This is new pixel, right? Then repeat step 6, step number of times. Repeat step 6, step number of times. You repeat step 6, step number of step number of times, right? This is how algorithm works. Then example, one example, consider line AB, which is a equal to 0, 0, b equal to 8, 4. Apply DDA algorithm and calculate pixels on the line. Here starting point is 0, 0, end point is 8, 4. That's why delta x is 8 minus 0, that is 8. Delta y is 4 minus 0, 4. And now delta x is greater than delta y. Delta x is greater than delta y. That is, so steps equal to 8. Steps equal to 8. How to calculate the steps? Again, use the previous algorithm. Then that here steps equal to absolute value of delta x. That is steps equal to 8. Then x increment is what? Delta x by steps. That is 8 by 8. That is 1. Then delta y is delta y by y increment is delta y by step. That is 4 by 8. That is 0.5. That is 0.5. Then starting point, you draw starting point first. You draw the starting point, that is y naught, x naught, that is 0, 0. Then what is the next point? Next point here. Then next x4. Next x4. If it is x2, then x1, x2, x3, x4. Like that if you take, then next x4 is x3 plus x increment. that is 3 plus 1, that is 3 plus 1, that is a 4. 3 plus 1, that is 4. Right, like that you can calculate intermediate term. Means this is x0, y0. x1, what is x1? x1 is 1. x1 is 1, right? x1 is 1. Then how to calculate x1? Again, say use the same whatever equation here you have used. This is, you draw first point, that is 0 comma 0, then new x. What is new x? That is old x plus x increment. Old x is 0. Old x is 0 here. Old x is 0. Then new x increment is 1. That is 1. Then y increment is, y is 0.5. That is 0.5. Y increment is y is 0. Y increment 0.5. Then 0.5 you are rounding up. Here you will round up. Here you will round up. Right? Like that you calculate here. Like that x3, x3, y3, x5, y5, x6, y6, like the same thing. x1, x2, x2, x3, all you calculate like the same equation. I have taken simply some examples. Right? Then once you come x3 when you are calculating x4, you know the x3 is 3. Then x increment is always 1, because delta always you will get x increment is always you will get n 1, because the slope of this line is less than or equal to 1. Slope of this line is less than or equal to 1. That's why x increment always you will get 1. Only you have to calculate the y you will get a problem. That's why here x is always, x previous x is 3. Then x increment is always 1, 4. Then what is y3? y3 is 1.5, because every time you are adding 0.5, 0.5. Then y3 is, previous y3 is 1.5. Then y increment always you will get 0.5. Y increment is always 0.5. That is what? 2. Then x4, y4 is 4, 2. x4, y4 is 4, 2. Here, then x4, x5, y5, you know x4 is 4. X increment is 1, that is 5. Then y4 is 2. y4 is 2, y increment is 0.5, that is 2.5. That is x5, y5, 5, 2.5. Like this you calculate for all. Like this you calculate up to 8, 4, because last value is 8, 4. Once you get 8, 4, then you stop. You stop, because number of steps will become 8. Because every time number of steps you are decrementing, once number of steps become 0, then you are nothing but 8 steps you are done. Then end point values are 8, 4. You stop here. Right? If I aggregate this one, if I write in a simple table, then number of steps are 8, then starting point is 0, 0, then new point is 0.1. 0.1, new point is 0.1, 0.5. Then round off function. If you take round off, then 1, 1, it will print 1, 1. Then starting point is 0, 0.5. This will become now starting point. New, it will become starting point. Then to this you will calculate new point. Right? 2, 1. Then 2, 1. Round off function will integer, both are integer, since it will display integer. Here, this will become now nothing but you are here, that will become starting point to calculate next point. From this to this you are calculating here, that is you will get 3, 1.5. Then 1.5 will be round up, that is 2. That is 2. Then you are here, means you are 3, 2. You are at 3, 2. Nothing but 3, 2 you are after rounding off, but actual value is 3.1, 3, 1.5. You are here, that is what your starting point. 3, 1.5. From 3, 1.5, what is the next pixel? That is next pixel is 4, 5. Then you will display 4, 5. Then now you are here. From this you have to calculate next point, that will come here. Then next point is 5, 2.5. Then like this you will calculate all 8 points. This is how DDA line drawing algorithm works. Right? As I told, limitation of DDA algorithm, the rounding operation and floating point arithmetic are time consuming procedures. As I told, rounding operation and floating point operations are time consuming procedures. Definitely they will take more time compared to integer operations. Right? The accumulation of round off error. The accumulation of round off error in successive addition of floating point increment can cause the calculated pixel position to drift away from the true line path for long line segment. Means when you are rounding off, nothing but 0.5 you added, means actually you got 0.5, but to this 0.5 already you added 0.5, means 0.5 plus 0.5 you got. If it is a long line, this accumulation, whatever 0.5, wherever you are getting, here keep on adding here 1.5, again 1.5 you added 0.5, that's why you got 2. If you do this one for a long length line, at that time this accumulation may increase. Here 1.5 to 2 you got, but suddenly this 0.5, every time if you add 0.5, suddenly actually you want 2, but suddenly it may happen that directly it will go for a 4. It will go for 4. That is what the meaning of this. Definitely it may drift away from the true line path for a long line segment. This is the limitations of this algorithm. To overcome these limitations, we have other algorithm, that is Bresenham line drawing algorithm, right? Again, there are solutions for this. Means to overcome this disadvantage, we have the newer version of the the other line drawing algorithm, that is Bresenham's line drawing algorithm. In that, we are removing the floating point operation. Working is same, but it removes floating point operation, right? This is regarding DDA line drawing algorithm. In next video, we will discuss next law, that is Bresenham's line drawing algorithm. Thank you.